Greetings and welcome, friends. Mr. Waddy here, and we are starting a three-part lesson about graphing linear equations in what's called slope-intercept form. Let's see, we are familiar with the word form. We had standard form last time. You might be familiar with the word intercept. We talked about a line having x and y intercepts. And today, we're specifically going to talk about the slope part of this. And so for slope, it says the following. The slope m, and I'm going to label m in green. And you might be like, why is slope the variable m, or the constant m? There ain't no m in the word slope. And I don't know. I don't know. I just don't know, guys. Okay, I don't know. It's probably because S was already used for side length of square, and L was already used for slant height of a pyramid. But M is like mountain, and mountains have slopes, and maybe that's why it's an M. I don't know. But it says the slope M of a non-vertical line passing through 2 points, and then they talk about 2 points. So here's the x-coordinate of the first point, the y-coordinate of the first point, x-coordinate of the second, y-coordinate of the second. And it says the following, that the slope is the ratio of the rise to the run. All right? Rise over run. All right? So the rise is going to be the change in the y, and the run is going to be the change in the x. And when I say run, we run to the right, okay? Like Mario. Mario runs to the right, okay? And sometimes to the left in some levels, I know, but the classic is to the right. Actually, with the new like Mario app game that came out a couple months ago, does he always run to the right? I don't know, probably. No, but then like you could double jump off of a wall and go left for a little bit, I think. Right, so the slope is going to be a ratio of rise to run. Rise to run. One of the ways you can find the rise is, notice, by subtracting your coordinates, the y-coordinates, right? How high is this minus how high is that? That's going to give you the change in y. And the run can be calculated by subtracting the x-coordinates, right? How far over was this point? Subtracting how far over is that point will change those. So here is what's called the slope formula, y2 minus y1 over x2 minus x1. Notice it's the rise, or the y's, on top, and the x's on the bottom. All right? And then, look, man, they're giving us so much facts today. They said when a line rises from left to right, the slope is positive. So positive slopes go up and then over. And when it falls from left to right, when Mario's going downhill, the slope is negative. It's going down some amount and over to the right. Okay, so let's put this to work, friends. It says describe the slope of the line. So they're asking about positive, negative. And then they want us to find the number that describes that slope. Okay, so for this line, we'll actually do this a couple different ways. Reading it off of the graph, to go from this point, Ethan, to the next point, I could find the rise by going up how many units? What's the rise here, Ethan? Yeah, it looks like 4. And what's the run? Looks like 6. And so my slope, it's rising, so this is a positive slope. Okay, that's the first thing I could describe. Notice it's going uphill as I go to the right. And the slope is 4 over 6, the rise over the run, and that reduces, by the way, to 2/3. So there's my slope. Notice I could also have found 2/3 if I found another point where the line crossed the grid. Notice if I went up 2 and over 3, that lands a point on the line. And then even from there, up 2 and over 3 would land a point on the line. So yeah, 2/3 makes sense, like so. Now, let's say I wanted to find this using the slope formula. Let's do that as well. I don't know if I gave you enough space. We'll find out. But if I wanted to, I could label these points x1, y1, x2, y2. It doesn't matter which point I labeled which, Devin. It doesn't matter. But once I pick them, I got to commit to them. So the slope formula, all right, would be m equals y2, which is 2, minus y1, which is negative 2, so 2 minus a negative 2, over x2, which is 3, minus x1, which is negative 3. All right, and if I simplify that, I guess I'll work horizontally. I usually hate working horizontally. 2 minus a negative 2, I'll work vertically, is the same as 2 plus 2, which is 4. 3 minus a negative 3, gentlemen, we're doing math class right now. 3 minus a negative 3 is 3 plus 3, which is 6. And notice I get exactly the same slope as I did there, which reduces to 2/3. So whether I read it off of the graph or use the formula gives me the same amount. All right, let's see. Adriana, what do you think about the slope of this line? Do you think this one's positive or negative? It's going to be negative, and why did you decide that? Yeah, it's going down as it runs to the right. And if I wanted to read it off of the graph, I could find any points where it happens to cross the graph. Those are called lattice points. Looks like I don't have one over here. Right, I want to pick points right where it crosses the x, right, the crosshairs of that point. And it looks like it went down. How many units here? 3. And because it's going down on the y-axis, we'll call that negative 3. So the rise is negative, and when the rise is negative, that means you're falling, right? And the run is, looks like 2. And that's in the positive x-axis, right? The negative's over here. So down 3 over 2 appears to be our slope, negative 3/2. Okay? So you can read the slope off of the graph, or you can read this or find the slope using the coordinates of your points and using the slope formula. Let's have you guys try these 3 problems. Find the slope for me and tell me if it's positive or negative. I'll walk around for a moment. So do this on your paper. On your paper. Papel. All right, I'm going to pick 5 cards. Tell me how to do these. All right. All right, mis amigos de internet. All right, let's have she's not here right now. Jimmy. All right. So Jimmy, do you think this is a positive slope or negative slope? Yeah, it's negative because it's going down, right, as we run to the right. So negative, I agree. And how far down is it going here? How many units? Down 2, negative 2. And what's it running to the right by? Like 1, 2, 3, 4, 5. Yeah. So the slope is rise over run. So it's going to be the negative 2. Yeah, negative 2/5, negative 2 over 5. And if I wanted another point, I could go down 2 and over 5 again, and that would be able to perfectly predict a point on the line. But we don't have to do that right now. All right, next person. Let's have Ethan. Problem 2, positive or negative? All right, I like it because it's going up as we run to the right. Mario's going uphill. And what's your slope be? How do I find that? Yeah, you could have done up 4 over 6. If you found another lattice point, you also could have done up 2 over 3. And either of those end up being the same thing, but we should always have the most simplified version. M is equal to up 2 over 3, 2/3. And notice up 2 over 3, up 2 over 3 would actually even land me more points on the line. Side note, regarding negative slopes, put your minus sign either in your numerator or out in front. I don't often put it in the denominator. So side note about fractions, negative 2 divided by 5 is the same as the opposite of 2/5, is the same as 2 over negative 5. And none of those are equal to negative 2 over negative 5. Okay, so that's like 3 ways you could place your minus sign. As far as the ones that we like, I like this one and this one for writing slope. It's kind of weird to write it that way. However, notice that I could actually, using this one, I could actually go up 2 and backwards 5 and land at that point, right? Up 2 and backwards 5. So sometimes you can switch it around if that helps you out. Let's see, next person, Cameron. You think the slope is positive or negative? Positive, because Mario is running uphill as he runs to the right. And let's see, for the slope, I'm going to pick a couple points that this passes through. How far up is it going here? Actually, whoa, wait a minute. What? They tricked me, guys. Wow, I almost fell for it. It went from negative 3 up to 4. So I think that went up 7. And then what's the over by? Yeah, man, that one was a tricky one. I had to pay attention to the scale. It almost fooled me. 7/3 is the slope. And also, I could have, by labeling this x1, y1, and x2, y2, I could use the slope formula. And in case I couldn't count my grid effectively, your slope formula would always help you out, giving you an exact answer every time. Todo de los tiempos. Let's look at example 2 together. Example 2, it's gonna be you. All right, so it says the points represented by each table lie on a line. Thanks for letting us know. Those are linear equations that are being represented there. How can you find the slope of each line from the table? And then it asks you, what is the slope? So guys, the rise will be the change in the y's. Okay? So notice this. If I pick any 2 points, I can find the rise by figuring out what did the y value change by. It went from 20 to 14. What's the way to describe that? Yeah, it's changing by 6. Is it going up or down 6? Yeah, it went down 6. And in that same change, what was the run? The run is going to be the change in the x's. To go from 4 to 7, it went, what was the run? 3. And so my slope, rise over run, is going to be, looks like negative 2. Which, if it's a whole number slope, you can represent it that way. But if it helps, you could think about it as going down 2 over 1. Down 2 over 1, right? Because negative 2 is the same as negative 2 over 1. Right, Amity? Right. And I only need 2 points to find the slope. But notice in this case, they also happen to give me, right, if I go down 6 over 3, that works. If I go down 6 over 3, that works. But they didn't necessarily have to give me a nice little pattern here with the x's. It still would have worked either way. All right, what? Look at part B here. What is going on here, friends? Well, you can have negative x coordinates. Here? Oh, because 20 to 14, it went down by 6. Yep. Okay, what's the rise here? What's this changing by? Yeah, 0. It's adding or subtracting 0. Okay, that's interesting. And what's the run? In this case, it went over 2 and over 2. And so the slope is going to be 0 over 2. What's that simplify to be? 0. This is actually going to be a horizontal line. Horizontal. Okay? Horizontal line actually is of the form y equals a number, and y equals 2 here is our horizontal line. And guys, we just made a connection. What is the slope of a horizontal line? 0. 0, right? The least steep terrain you could walk on would be a horizontal flat terrain, and it has 0 slope. Big idea. Horizontal lines have 0 slope. Okay, let's check this last one. What's the rise? Going from -3 to 0, it went up 3. I like it. And what's the run? Plus 0. My slope is 3 over 0. Uh-oh. That is undefined. That's okay. In this one case, that's okay. You're right. Because of the plus 0 in this one case, it works out. Question? If x doesn't change, you could call this, by the way, right, the slope won't work. You could say that this line has a slope that is undefined. You could also call this no slope. All right, is a way you could describe that. And what do you think this? What's happening with the graph here? Does anyone know what kind of graph that is? This one, yeah. This is actually going to be a vertical line. And this is actually the vertical line x equals -3. And it turns out vertical lines are so steep, right? You could say, oh, you're going up 3 and over 0 and up 3 and over 0. You're practically saying you could go up infinity and you never go over, right? It's just a straight up and down slope. And so that is going to be the slope of your line. Okay? So that's the big idea there. Here, let's summarize this. So vertical lines also, remember, we decided were not functions. It didn't pass the vertical line test. Let's see. So positive slope, Mario runs uphill as he goes to the right. Negative slope, Mario's going downhill as he runs to the right. 0 slope, perfectly flat. Horizontal line. And an undefined slope, it's just straight up and down. It is, right, you're just climbing a cliff here, basically. And you're never going over is what ends up happening. All right. Well, thanks for watching, internet friends. Have a great day.